Shade the solution set in the xy plane. Use a test point to check your graph. We have the system negative 2x plus y is greater than or equal to 3, and x minus 2y is less than negative 3. So, to graph the first one, let's first put it in slope-intercept form. And that means we would need to add 2x to both sides, giving us the result y is greater than or equal to 2x plus 3. To graph the boundary line, we actually change the inequality to an equal sign, and so we have y equals 2x plus 3. This line will be drawn as a solid line because of the equal to part of the inequality. We have a y-intercept of 3. We have a slope of 2, which normally we would say go up 2 and over 1, but in order to keep it on the graph, what I'm going to do is a little bit of a trick to say the slope is really negative 2 over negative 1. Because, of course, negative 2 over negative 1 is positive 2. But that allows me to go down 2 and to the left 1 unit. That gives me the point negative 1 comma 1, and I now draw a solid line that goes through those points. Looking back to the inequality, it's y is greater than or equal to 2x, and that means we want y values that are more than this, that is, they are above the line. So we would shade that half plane that is above the line. Let's go back now and do the second equation. We want to put this in slope-intercept form, and that means subtract x from both sides. So it would be negative 2y is less than negative x minus 3. Now we need to divide both sides by the negative 2. Recall, though, that when we divide by a negative, we need to reverse the direction of the symbol, so this becomes y is greater than. We have negative divided by negative, so it's positive 1/2 x. We have negative 3 divided by negative 2, so that's also positive, but it's positive 3/2. So our y-intercept is going to be the 3/2. To draw that boundary line, we change it to an equation of y equals 1/2 x plus 3/2. Because the inequality is a strict inequality in the sense that it does not have an equal to part, then we draw a dashed line. Starting with the y-intercept of 3/2, that's 1.5. With a slope of 1/2, we would go up 1 and then over 2. We would now draw a dashed line that goes through those points. Once again, returning to the inequality, y is greater than 1/2 x plus 3/2. That means we want the y values that lie above this line. Let me use a slightly different angle and draw or shade in that area that is actually above my dashed line. Again, this dashed line does continue in both directions, so let me put my arrowheads on there. Now we look to see, where do these two graphs overlap? It's clear, as you can see up here, that it's the area where I'll call it the cross-hatched area, where we have the intersecting shaded regions. Over here, it's maybe not as clear to see, but it begins at the dashed line. And we're going to shade in the area above that. Then it becomes the solid line here. And so what we do is we shade in this area where the two graphs overlap. Now, let's pick a point, a test point, to verify what we have. Let's pick this point right here, which is -2, 3. So I'm going to use -2, 3 as my test point. So what I do is I substitute -2 in for x and +3 for y. A -2 times a -2 is +4. Plus 3 is 7. 7 is certainly greater than or equal to 3. And therefore, our test point of -2, 3 satisfies the first inequality. For the second inequality, we substitute -2 for x, +3 for y. 2 times 3 is 6. So we have -2 minus 6, which is -8, and that's certainly less than -3. And so the test point also satisfies the second inequality. So we've used -2, 3 to check our graph, and we have shaded in the correct part.